So now we're going to go through lesson 3.5, which is pretty much all about problem solving. So we have, remember, Polya's 4-step procedure for problem solving. So when you go through any problem, you want to first understand the problem, figure out what's given to you, what's unknown, try to come up with some type of plan before you actually solve it, perform that plan, and then check your answer. So again, checking your answer may not physically mean plugging it back in and seeing if it works, but checking if it's reasonable. So if it's reasonable, you want to make sure it makes sense for that specific type of problem. You're not getting that you need 300 gallons of paint to paint a single room. So if it's too intensive, just go through the process of, does this work? Okay? So let's go through a problem together, and then what I'd recommend is after the class portion I go through, kind of do it on your own and see if you can figure it out. So there's a blank Word document in Canvas. Go through it, see if you can get it done by yourself, and then kind of refer to the video as needed. So the first thing we're given, Jack and Diane are going to start saving for retirement. They deposit $1,000 in an account, and then they're going to deposit $50 each month. So we want to figure out how long will it take until they've deposited $4,500. So there's a bunch of information that's given to you at once. The first thing is you're starting with $1,000, and then you're going to deposit $50 each month. The thing we need to answer is how long will it take until they've deposited $4,500. So how long until we reach $4,500? So our answer should include some type of time, and it should be something reasonable. It should not take us 80 years to get $4,500 in the account. So we're going to go through this two different ways. We're going to first just kind of use arithmetic to help us out, and then we're going to apply some algebra to see if we can generalize this process. So how much is added each month is $50. We're starting with $1,000, so what we need to add is $4,500 minus $1,000. So we're doing $50 each month, which means $3,500 needs to be added. Okay. So using arithmetic, if this is how much needs to be added, and we're doing this, or we're putting in $50 per month, let's take the total we need to add in and divide it by how much we're adding per month. So if you take $3,500 and divide it by 50, it's going to take you 70 months to deposit $3,500. So let's check our answer by seeing that that works. If you take the $50 and you times it by the 70 months and add that initial $1,000 back, you do get $4,500 in the account. So we did do this correctly. Now what we want to do is we want to kind of make this involve some variables instead. So we're going to let M represent the quantity that can change. So M is going to be the number of months that you're going to deposit this money for. So an equation we really can write is you're taking that $1,000, you're adding $50 for an unknown amount of months, so you're adding 50 times N. And in total, this needs to equal $4,500. So if we use the techniques to solve this, subtract 1,000 from both sides to make the thousands cancel on the left, you get 50M equals 3,500. Dividing by 50 makes those cancel. And then we've already done 3,500 divided by 50. You get the same answer. M is equal to 70 months. Okay. So now we're going to kind of come up with a general framework. Instead of depositing $1,000 initially and $50 per month after that, Let's see what happens if we want to deposit like $30,000 and we're going to input $100 each month and we want a new total. Is there a different way we could find the exact amount of months we need for this total amount? So we're going to have a bunch of variables. We're going to let M still represent the number of months we're going to deposit the money. T is going to be the total amount we want in the account. I is going to be our initial deposit, because that could change if we decide we're going to do a different plan. And then D is going to be the amount we deposit each month. So let's call it our monthly deposit. So what we have is we take our initial deposit, we're going to add D amount of dollars, and we're going to do that for M months. And we want to see how long will it take to reach some total. So if I know that I want $30,000, say, in a savings account for my child, I'm going to put $5,000 in initially, and I'm going to do $100 each month. We could reverse this to figure out how much we need or how many months we would have to do this for. So we can solve this equation for M. So let's subtract I from both sides. So that gives us D times M is T minus I. And then dividing by D makes the D's cancel. And we get the number of months we need is the total amount we want in our account minus the initial deposit divided by how much we're going to deposit each month. Okay, so that generalized the framework and really gave us kind of a simple example. The group work's going to be a lot harder, but this is the process you want to follow. Write down the relevant information. You can read the whole problem once, but you're going to have to write stuff down and reread over and over. So try to write it as you come to it. Then identify what is it you're searching for. How can you find that? And read it again to make sure you understand what's going on. So I would highly recommend at this point going through, attempting these on your own, and just coming back to the video when you need. So suppose that you have 4 people in your family and you want to hang a picture of each family member. So the wall we choose is 60 inches wide and each picture frame is 8 inches wide. To make everything look right, you want to make the wall space between the edges of each frame identical, and the same amount is going to go on the ends of the wall. Each frame has a single hook in the center of its back, and we want to figure out where should you put the 4 nails to hang these pictures. So for our relevant information, we have 4 frames. They're 8 inches wide. The nail is going to go in the center. And the wall is going to be 60 inches. Okay. So what we need to find is we need to figure out where do we put the nails to have equal space between the frames. Okay. So now we want to draw a picture to go ahead and help us out. So we've got our wall here, and that's going to be 60 inches. We're going to have the 4 picture frames, and each of these is 8 inches. Then we're going to have the nail, which is going to sit exactly in the center of the picture frame. So it'll go up top, so each side will be 4 inches because halfway into 8 is 4. So each side is 4 inches. So the only thing we need to figure out to be able to answer where these nails go is how much space needs to go in between each of these photos and at the end. So it's all going to be equal space, so let's just call it X. So the first thing we want to do to figure out that is, given those 60 inches, let's figure out how many are covered by, how many inches are covered by the picture frames. So in total, you have 4 frames that are 8 inches each. So 32 inches is covered by the picture frames. There are 5 empty spaces because you have to put one on each side at the end. And each of them, we don't know what they are, so we're giving it that variable quantity. We're going to let X equal the width of each space. Okay? So now that we have that, we can come up with an equation. So 60 inches is how long the wall is. That's going to be the 32 inches taken up by the picture. And we've got 5 empty spaces that are X width and length each. So in total, that has to equal 60. So if we go to solve this, we want to solve for X. So we subtract 32 from both sides. 60 minus 32 is 28, and that equals 5X. So to solve for X, you divide by 5, and you get X is equal to 28 over 5, which is just going to be 5.6 inches. So what that tells us is each one of these spaces is 5.6 inches, every single one of them. So now that we know this, we can actually fill in how far each picture has to go. Okay? So the first picture frame starts at the wall. It goes 5 plus 6, 5.6, and then the 4 inches in. So the first picture is 5.6 plus the 4 inches to the half a picture frame. So the first picture, or the first nail, should be 9.6 inches from the wall. So 9.6 inches to the first nail. Then, for every nail after that, you've got to go these 4 inches, the 5.6, and then 4 more. So you have 4 inches to get out of the picture frame, the white space, and then 4 into the next one. So you want to go 13.6 inches from there. So from the first nail to second. And then likewise, for these other 2 frames, it's exactly the same. 4, 5.64, 4, 5.64. So it's the same for the third and fourth nails. So you do 13.6 inches from the previous one. So we're going to check that in our diagram, that we did do this correctly. Let's not make it so big. Need some space. We've got 1 picture, 2 picture, 3 picture, 4 picture. The first picture frame is going to be the first nail is 9.6 inches in. And then it's 13.6 inches from there. 13.6, 13.6. And then you need to go 4 more inches to the end of the picture frame and another 5.6 inches from the white space. So in total, if you add up all of these, 9.6 plus 13.6, 13.6, 13.6, the 4 inches, and then that final white space, you're going to see that yes, it does actually equal 60 inches. So you've done this correctly. So this is one problem we can actually check. So we can generalize this a little bit. Suppose we want to add more pictures. Maybe we want to change the width of each picture. If we kind of go back to where this equation came from, the 60 is the total width of the wall. So that's exactly this total width we get in this formula. Now what we also have is this 32, which is the amount taken up by the picture frame. So the number of pictures times the width of each picture tells you exactly how much is taken up by frames. And then this last component is going to tell you how much is taken up by the blank space. So you see we had 5 times x. There were 5 blank spaces, which is 1 more than the picture frame, times the width of each. So if we want to generalize this with an equation, we have a couple variables. We're going to let t equal the total width of the wall. We're going to let n equal the number of pictures. And we're going to let w equal the width of each frame. So a nice equation that can help us is you take the number of pictures and times it by w. That's the total amount taken by the picture frames. We'll add to that the number of pictures plus 1, so n plus 1. That's our number of blank spaces. Times it by that width of each blank space. And in total, this should equal the total width of the wall. So if we plug in the numbers from our previous problem, the number of pictures was 4, the width of each picture frame is 8, and the total length of the wall is 60. So plugging this all in, you get 4 times w, which is 8, n plus 1 is 4 plus 1, x is that unknown quantity, the width of the blank space, and the total wall is 60. So if you simplify, you get 32 plus 5x equals 60, which is exactly the same equation. So this is our general framework for this particular problem. So now if we want to kind of extend that, maybe we decide to adopt a puppy. Now we want to put a 5th picture to hang on the wall. And we want to do the same work, but now I don't have to go through this same process. I've got the framework down. So we're going to take the number of pictures times the width of each picture, plus the number of pictures plus 1 times this blank space, which is what we need to find. This should equal the total width of the wall. So now we have 5 family members. So we have 5. The width of each picture frame is not going to change. It's 8. The number of blank spaces is now 5 plus 1. And the width of each blank space we don't know, that's x. But we're keeping this on the same wall, so this still has to equal 60. So now the amount of space taken up by pictures is going to be 40 inches. We have 6 blank spaces that are x inches each, and that better account for my total wall, which is 60. So to solve for x, we subtract 40. And that gives us 6x equals 20. We divide by 6. And that gives us x is 20 over 6, which if you plug in a calculator is around 3.33 inches. Okay? So now we know the width of our space. Instead, we've got 5 picture frames. Make it a little longer. Each of these is still 8 inches, but now these are all 3.33 inches. And the nails are still going to go halfway in between. So if we want the location of the nails, the first nail is at 3.33 inches plus the 4 for half the picture. So you should put the first nail at 7.33 inches. The second nail is you start at the previous nail, you add the 4 to go through half the picture, the 3.33 for the blank space, and then another 4 to go through the second half of the picture. So you should go 11.33 inches after the first nail. And then likewise, it's the same for third and fourth nails. So this is much better than starting from scratch because I didn't have to repeat this process over and over. I could just take this formula that generalized the problem and plug in these new values. So generalizing saves time. So we don't redo work. So now we're going to try one more example, and then we'll try to generalize that and use the same information to help us. So we're told the riding lawnmower in the classic movie Forrest Gump had a 28-inch cut that averaged about 4 miles per hour. A standard football field is 120 yards long by 160 feet wide. We want to figure out how long would it take Forrest to mow a football field with this machine. So we have a lot of information given to us at once. So what I'm going to do here off to the side is I'm going to draw a little picture of what's going on. So we've got a football field. This is 160 feet by 120 yards. Okay. So what's going to happen is Forrest is going to mow his lawnmower up in this direction, and it's 28 inches that he's going to cut. He's going to turn his lawnmower around, drive it back the other way, 28 inches again. And he's going to keep making these passes until he gets through the entire football field. So you can tackle this problem in a bunch of different ways. I think the easiest thing to do is you first want to figure out how many passes is he going to make. And then you want to figure out how long for each pass. If you can figure out these two things, you just multiply the two together, and that tells you how long it'll take to mow the football field. So first, let's figure out how many passes, and then that'll tell us how far he's going to actually have to travel. So he's got 160 feet. We need to first convert that to inches. So he's going to cut through 160 feet. If we convert that to inches, we need to get rid of feet and introduce inches. And 1 foot is 12 inches. So this causes our feet unit to cancel. And 160 times 12 is 1,920 inches. Okay. So this 160 feet is 1,920 inches. Since each cut is going to be 28 inches, we want to see how many times does 28 go into 1,920. So we want to take this 1,920, divide it by how wide each cut is, and you'll see this is going to equal 68.9, but he can't make 0.9 of a cut, so he's going to make 69 passes. Okay? So each one of these passes is going to be 120 yards, 120 yards, 120 yards, 120 yards, 120 yards. And he's going to do 69 of these. So let's figure out his total distance he's driving. The total distance is going to be the number of passes, which is 69, multiplied by the 120 yards. So in total, he's going to drive 8,280 yards. Okay. So this is the total distance he's going to drive. We want to see how long will it take him to go this far. So we've got the rate. We know he can go 4 miles per hour. So we need to convert this 8,280 yards into miles. So first, we need to get rid of yards, but the only conversion I know is feet. So 1 yard is 3 feet. So this makes our yard unit cancel. Then we want to get rid of feet and introduce miles. And then 1 mile is 5,280 feet. So this makes the feet unit cancel. So what we're left with is 8,280 times 3 over 5,280 miles. This is how far he's going to travel in miles. So if we take this number, which is the amount of miles, and we multiply it by 1 over its rate, or multiply it by its rate. In 1 hour, Forrest is able to go 4 miles. So by multiplying by this version of the rate, the miles are going to cancel and all you're left with is hours. So it's going to take 8,280 times 3 divided by 5,280 times 4. So if you plug this into your calculator, you're going to see it's going to be about 1.18 hours. So this one's very difficult to check, but you can think intuitively about an hour to mow a football field does seem reasonable. So this seems okay. He makes. So you're going to take the 1,920 and divide it by the width of the lawnmower. So what this does is it's going to be the number of passes that he must make. Now you want to multiply it by the length of each path. So we multiply this by 120 yards. And what this does is this gives us the total distance he has to drive. Okay. So once we have the total distance, that's what we converted into miles. So you need to get rid of yards and introduced feet. So 1 yard is 3 feet. And then you need to get rid of feet and introduce miles. So 1 mile is 5,280 feet. And now lots of units cancel, so the yards are gone, the feet are gone, we're just left with miles. You need to times this by that rate. So he's going to go 4 miles in 1 hour, or in any case, he's going to go R miles, more generally, per 1 hour. Okay. So this will cause the miles unit to cancel, and you'll just be left with hours. And this will equal the total time for one field. Okay. So what's left is 1,920 times 120 times 3. The 1 and 1 don't do anything. In the bottom, you have W times 5,280 times the rate that he's going in miles per hour. So for this specific example, we're told that the width of the blade is 54 inches and the rate is 9 miles in 1 hour. So it will take him about 0.27 hours to mow one field. So if he wants 2 fields, you would take this time and multiply it by 2. So it would be 0.54 hours for 2 fields. So this is pretty decent. It's not perfect though, because again, it doesn't take every single piece into account. The main thing we're not accounting for is he's making this pass, he's going forward, he's got to turn around. So in the case that he's making 70 passes, if the turnaround even takes like 10 seconds, that's still extra time that's added on. So we're not accounting for turnaround time. Okay, so to make it more accurate, if we figure that out, multiply by the number of turnarounds, and add it to the total, our answer would be more accurate. Okay, so the only way to get better at these types of problems is really to just practice on your own. So I would highly recommend going through and trying more examples as you can.